Today I'm going to be making phenytoin, a commonly prescribed medicine used to treat seizures and epilepsy. It's a quite cool drug since it has much fewer side effects compared to other anti-seizure drugs such as carbamazepine and lamotrigine. I'm going to be starting with benzaldehyde, which is commonly found as bitter almond oil. I'm then going to be turning it into benzoin and then benzyl. The benzyl will then be reacted with urea, which I extracted from my own pee, to make phenytoin. If you want to check out the video where I extract the urea from my own pee, it's linked in the description. Alright, so to begin with the synthesis, I first dissolve 1.68 grams of sodium hydroxide in 14 ml of water. I stir it around for a while and eventually all the sodium hydroxide dissolves. The mixture gets quite hot, so I place it in the freezer while I prepare the second solution. To the new beaker, I add 7 grams of thiamine hydrochloride in 16 ml of distilled water. The thiamine quickly dissolves, and once it's all gone, I add 70 ml of isopropyl alcohol. I put the solution in the freezer as well, and I take them out when they're both 0 degrees Celsius. I then place the thiamine solution on a stir plate and turn on the magnetic stirring. I now slowly add the sodium hydroxide solution in small portions. The thiamine reacts with the sodium hydroxide to form free-base thiamine, which gives the solution a yellow color. We're making the thiamine because it's going to help catalyze the next reaction. Once we added all the sodium hydroxide solution, I let it stir for a few minutes, and then I add 40 milliliters of benzaldehyde. I then place the beaker into a hot water bath at 60 degrees Celsius and stir it in the water bath for 2 hours. The thiamine causes 2 molecules of benzaldehyde to condense together and form 1 molecule of benzoin. The reaction is not very efficient and the yields are typically pretty low. The reaction is also pH sensitive, and I tested the pH and it seems to be around 9, which is perfect. 2 hours later, you can see the reaction got a lot darker. The reaction should be over now, and I took away the hot water bath and I let it cool down slowly. As it cooled down, all the benzoin crystallized. Once it was room temperature, I put it in the freezer to crystallize as much benzoin as possible. I then vacuum filter off the benzoin and wash it with some water. I pull a vacuum on it for a few hours to dry it. We now have some crude benzoin. I recrystallize it from some isopropyl alcohol to clean it up. Again, as it cools down, the benzoin crystallizes. I again filter off all the benzoin and I dry it. The final yield of pure dry benzoin was 19 grams, which is a 46% yield. We can now convert the benzoin into benzyl. To do this, I add 70 milliliters of concentrated nitric acid into an Erlenmeyer flask, followed by all the benzyl that I just made. I let it stir for a few minutes, and then I place it into a warm water bath at 70 degrees Celsius. The nitric acid oxidizes the benzoin into benzyl, releasing nitrogen dioxide gas. Nitrogen dioxide is very toxic, so it's important to be careful here. As the mixture heats up, you can start seeing the reddish-brown nitrogen dioxide being released. The reaction kept going for around an hour and a half, but eventually died down. Once it stops releasing gas, you can take off the water bath. As you can see, the mixture separates into 2 layers, with the upper layer being the benzyl. I then dump the mixture into 200 ml of ice-cold water. As you can see, the benzyl precipitates. I stir it for a while just to make sure all the benzyl has crystallized, and then I vacuum filter it off. I then recrystallize the benzoin from some isopropanol. Unfortunately, the benzyl didn't crystallize and it just oiled out. So this recrystallization was a bit of a fail. However, when I put a stir rod in and started mixing it around, the benzyl immediately solidified. I then heat everything up again to get all the benzyl to dissolve again and try again. This time, however, I placed the mixture into a cold water bath, hoping that the fast change in temperature would promote crystallization instead of oiling out. Long story short, this failed as well, but at least I was able to get this cool shot of the benzyl slowly crystallizing. This shot is not sped up, and it's in real time. I ended up speeding it up anyways because it was a bit too boring. Anyways, I again vacuum filtered off the benzyl and dried it. I unfortunately lost the footage of the benzyl when it was dry, but the final yield was 16.2 grams, which is an 86% yield. It's now time to turn the benzyl into phenytoin. I add 10 grams of the benzyl that I just made into a round bottom flask, followed by 5 grams of the urea which I got from my own pee. I then add 150 ml of 95% ethanol. In a separate beaker, I then dissolve 16 grams of potassium hydroxide in 30 milliliters of water. I then add the solution into the benzyl urea mixture that I made earlier. As you can see, it quickly turns dark brown. I then set up a condenser on top of the flask and refluxed the mixture for 2 hours. 2 hours later, it lost a lot of the dark color and became a lot lighter. The benzyl, urea, and potassium hydroxide react to form potassium phenytoin, which dissolves into solution. Once the reflux is over, I dump the mixture into 350 ml of ice-cold water. As you can see, some stuff precipitates. This precipitate is not the potassium phenytoin, since potassium phenytoin is water-soluble. This precipitate is probably unreacted benzyl and some other side product. Anyways, I stir it for a few seconds and then I filter everything through a cotton ball. Once everything filtered through, I was left with a nice dark red solution. To separate the phenytoin, I add dilute hydrochloric acid. The potassium phenytoin reacts with the hydrochloric acid to form insoluble free-base phenytoin. The phenytoin crashes out of solution as an off-white precipitate. I keep adding hydrochloric acid until the pH is around 1 or 2. At this point, I put everything in the freezer for a couple hours to precipitate as much phenytoin as possible. I then pass it through a vacuum filter to isolate the solid phenytoin. I was left with a bunch of dry, crude phenytoin. I recrystallize it from some more isopropyl alcohol to purify it. Here's another quick time-lapse of the phenytoin crystallizing. I then again vacuum filter the phenytoin and dry it. In the end, I was left with 4.6 grams of nice and dry, pure phenytoin. Since it's in its free-base form, it can't be taken as a pill since it's insoluble in water. To take it as a pill, it needs to be converted into something like sodium or potassium phenytoin like it was earlier. Anyways, this yield is around a 38% yield from the benzyl. If you multiply all the yields from each step, we end up with a 15% yield from the starting benzaldehyde. Even though we recrystallize it and it's still pretty pure, it's not the best idea to ingest anything you make in the lab, even though it still seems pure. So it's much better to just buy phenytoin from the pharmacy, or get it prescribed to you by a doctor. Anyways, I think this project was pretty cool, and it was quite fun to turn my own pee into an anti-seizure drug. If you enjoyed the video and found it fun and entertaining, I highly recommend you subscribe since I make videos like this every week.